Hello guys, this is Milos. Welcome back to my channel. I've recently discovered some awesome shipping traffic density maps done in Python and Blender, and I wanted to show you how we can make some similar maps in R. Folks, our first step will be to install and then load packages that we need. For that purpose, we'll be using the pacman library, and if you don't have this one, you should definitely install it using install.packages from base R. Now I have this installed, and then I can use one very convenient function called pload, which is gonna install the packages that are not already installed in my system, and then it's gonna load them. What I just need to do here is provide the names without any quotation marks. And the first one we'll use is the tidyverse package. From this one, we'll be using ggplot2 for data visualization. Then we need the Terra package for working with raster files, since both of our sources are gonna be raster files. Then we of course need the asset package for dealing with polygons. And then for getting the polygons, we can use gsco-r for getting any national or regional boundaries. And finally, we'll be using one very new package, which is called ggNewScale, which allows us to add another fill scale to our ggplot2, which otherwise it's not possible with base ggplot2. Okay, our second step will be to download, unzip, and then load the ship traffic data. So the first thing is to find out where we can get the data from.
And the data on shipping traffic density comes from the World Bank. We're here at datacatalog.worldbank.org, and over here you should enter the keywords. So for example, shipping traffic, then you click here on the scope, and what comes next is actually are the search results. So you should take the first one, click on the global shipping traffic density, which is going to take you to yet another page with the main information on this dataset. So this dataset was obtained through a partnership with IMF, and the dataset actually contains 6 layers here. So it has for the global ones, which we are going to be using, and that's the biggest one. It has on commercial fishing ships, as well as oil and gas, passenger and leisure ships. So we're going to be using the one here on global ship density. As you can see, it's 510 megabytes, so it's quite big, but once we actually unzip this, so this is a zip file, there's going to be even more. If you're more interested about the metadata, you can also expand here. You can see the description, so it's at 500 meters resolution. And this one takes the average, so the average shipping traffic density for a 5-year period between 2015 and 2020. All right, so in order to actually download this dataset, what we want to do here is we click right on this global shipping density here, and then we copy the link address, which we will next use in R to download this dataset locally. Okay, once you copy that link, you can paste it here. And as you can see, it's quite a long one. What is important for us is after the zip extension to remove everything starting in question mark forwards, because that is not going to allow us otherwise to download this. So you remove this, and the last thing you want to see here is the zip extension. Now, once this is done, what you need to do next is you need to declare this as a URL. First of all, we need to put double quotation marks around this so that we declare it a string. And then we can assign this string to this URL object. Now that we have this, what I want to do is I want to fetch the file name from this link. So the file name is ship_density_global.zip. And the easiest way to do that, I'm going to call this test file. The easiest way to do that is to use base name function from base R, which is going to grab that. So once this is ready, we can go ahead and download. But before you download, what I would suggest you to do here is to set in options a timeout, which is higher than the default one. And I would put here to 999 seconds, for example. So this is going to be over 9 minutes. And if this doesn't work for you, of course, you can increase that. The reason why we're doing this is that this file is quite large. It's not large at the moment, but once we actually unzip it, it's going to be pretty big. So the first thing we want to do in downloading is use this download.file from base R. Then for the URL, we can define here the URL. That's the first thing. Then for the destination file name, we also can use this object, which we previously defined. And then finally, for the modes, we use the binary mode denoted here by .wp. All right, once this is ready, what we need to do next is to unzip this file. Unfortunately, this file is going to yield
over 6 GBs of data, and we cannot actually use the unzip from base R because this can only deal with files up to 4 GBs. So in order for us to do this properly, I found actually one function on Stack Overflow which is going to help us. It's called decompress file, and shout out to the creator of this one. So what I actually did, I simply downloaded this to my local drive, and now I can call it using source from base R. What I just need to do is I need to call it here decompress_file.r, and this is going to load it. Now in your case, I will definitely provide this in the GitHub repo, so you can also load it easily into your session. Once we have this, we can use the function which is called decompress file. Now this function takes 2 arguments. So the first one is directory. This is where you actually store currently your downloaded file. Now, I store it in my current working directory, so I'm just gonna grab it here. And then the next argument that you wanna do is you wanna provide the name of the file that you want to unzip. So in our case, this is this test file. And then the final part of this step is to actually load this file. Now, what we need to do here is we need to load this raster file, which has the same name as a zip file. We just need to change the extension. And to change the extension, we can use gsub, which is very good for editing file names. So this one takes actually 3 arguments here. The first one is the pattern that you are looking for. So we are looking for .zip file, assuming this is the only zip file we have in the current working directory. The second one is what you want to replace with. So this is a raster file, so it has a TIFF extension. So I want to replace it with a TIFF extension. And then the file name is, of course, this dest file. And then once you have this raster file here, you can just load this global traffic data using Terra Rust function and just passing here a Rust file. We quickly inspect this raster file. We'll see that it's quite actually big in terms of the dimensions. Resolution is also quite nice, and it covers the entire globe. And the coordinates reference system for this one is the WGS 84 coordinates reference system. You can also see the minimum and maximum values, which at this point don't make much sense given that we're going to use it for a given area, and we're not actually going to show the legend in the final map. So we loaded the global ship traffic density data, but I'm going to show you here how you can crop it only for the area of your interest. Next thing, we're going to go ahead to a website where you can get the coordinates for a bounding box of any region of your liking. And then we're going to use these coordinates to create a bounding box polygon, and then finally crop this global ship traffic density data. So the website from which we will getting our bounding box coordinates is called bboxfinder.com. We use it in some of the previous tutorials to do the same thing. What I'm going to do here is use this one to select the area of interest. And actually what I'm going to do here, I'm going to actually move here. I'm just going to zoom in. And then what I'm going to do next is I'm going to use this draw a rectangle from the menu on the left hand side. So I'm going to click on that one, and then you can see now that it transitions into this cross. And then what I'm going to do next is I'm going to select some random area around here. And once I'm actually happy with this area, I'm just going to deselect, and it's going to give me here these options. Now, what you want to do next is I want to transition to the bottom of the screen. And over here, you will see something which is called mouse, box, map, and center. You want to go to the box area, and then you want to actually select these coordinates just as I did. These are minimum and maximum longitude and latitude coordinates, which actually define this bounding box that you see here. And then what you want to do next is you want to go ahead and copy them, because then we'll go back to R and create a polygon based on these coordinates. All right, going back to R, I pasted here those 4 coordinates points. And then the next thing what I'm going to do is I'm going to define them, and then I'm going to pass them to SF and create a polygon. Now, the first element here is the minimum longitude value, denoted here by xmin. So what I'm just going to do here, I'm going to copy this and paste it here. And then we have here, the next one is the minimum latitude value, denoted by ymin. So I'm going to do the same here. I'm just going to go ahead and copy this one here as well. Then the next one is the maximum longitude value, denoted here by x max. For those of you who are not familiar, so x is used for longitude and y is used for latitude. So again, I'm just gonna go ahead, cut this one, copy here, and finally the last one is the maximum latitude value, which again I'm gonna go ahead, cut and paste here. Okay, now that we have this defined, we can go ahead and create our polygon bounding box, and I'm just gonna conveniently call this bounding box. Then, first of all, we're going to be using SF package here. And from SF package, we'll be using this function, st as sfc, which is converting a foreign geometry object into an SF object. That's the first thing. The second thing is we want this object to be nothing else than a polygon. So I'm actually coursing this into a polygon. And then the polygon, of course, is a list of coordinates, these 4 coordinates that we have. So we need to go ahead here and put them into a list and also do a column-wise binding of these. Now we're going to have 2 actual lists here. The first one is going to be the list of longitude coordinates. So it goes like this. The first one is going to be the x-min, then it's going to go to the x-max, then again it's going to be the x-max, and then after the x-max, we're going to have x-min twice. So x-min and then x-min. Okay, so this is the first list. The second list concerns the latitude coordinates. So those are those y-min, y-max. All right, so we're going to go like this. Y-min followed by y-min, then y-max. Then again, we're going to have y-max. And then finally, the fifth one is going to be again the y-min. Okay, so this is going to create a bounding box polygon, but what we need to do here before we actually close this off is we need to define the coordinate reference system, otherwise R is not going to know. So this is also WGS84 coordinate reference system, and in R it takes this one EPSG 4326. So you need to pass here 4326. Now, once this is defined, what you need to do next is you need to actually use this bounding box polygon and then crop this global ship traffic density raster file. So we're going to go ahead here and we're going to create an object called shipping traffic. So shipping traffic, and then shipping traffic, we will crop using Terra crop function. So Terra crop function is the following. It accepts 3 arguments. The first one is the X argument, which is basically what are you gonna crop? What is the raster file you're gonna crop? So global traffic. The second one is the Y argument, and this is what is the SF object that you're gonna use. Well, we're gonna use this bounding box polygon, so I'm passing that. And then the final argument here is that we want to only take the features, that the content that is inside of the bounding box. All right, so if you run Terra plot function, passing this object to it, you should be able now to see the ship traffic density only for that cropped area. One thing you notice that we have 0 values, which are essentially for the interior of the landmass, which of course mostly doesn't have ship traffic density, but in some cases, for example, if rivers are used, they do have. Now what we want to do is we want to declare those zeros as NA values so that we can actually then omit them and then give the space for the Nightlight data that will come next, that will fill that landmass with information, of course, on the cities. So what we're going to do here is we're going to utilize from Terra a function which is called if-else. What essentially this function does is if the condition is met, then you can make a change for that condition. So what I'm going to do here is create a new object, which is going to be called shipping traffic clean. I'm calling it clean because I will, of course, change the values. So what I'm going to put here is for that older file, shipping traffic, if the value is equal to 0, I want to change them to NA. Otherwise, just return shipping traffic object value. So what this does is simply if-else statement. Now, one thing you notice over there is that because we're working with ship traffic density, the continental area, the interior area is simply absent. So I wanted to fill this gap not with something, too simple. I wanted to actually give it a very nice glow. So I decided to go with the Nightlight data so that we can actually see the populated places, especially cities, glowing in the dark while you have ship traffic density around the land mass. So what I did actually here is I copied here and pasted the link from one of the previous tutorials where we actually worked with Nightlight data and where I showed you how you can create effective swipe Nightlight maps. So what I essentially did here, I pasted here the link to the global average Nightlight values for 2022. And this one is average masked. So basically it takes only into account the existing values, so it doesn't take into account the missing values. And what actually we need to do now here is, just as we did with the previous one, in order to download this file, we need to first of all declare this as a string object, and then we need to pass it to an object here in R, which I'm going to call U, just a shorthand for URL. And then, as we did also for the ship traffic density file, we're going to actually create here a file name using a base name function and passing here this object U. And then again, we're going to be using the download file as well. But here for URL, we're just going to be passing this U object. And also for the destination file, we're going to be passing this file name. And then finally, for the mode, we're going to be using here a binary mode. All right, once we actually download this file locally, we can get it directly into R because it's not zipped, and you can see it actually from here. And it is actually gun-zipped, but what we will do here is, just as we did in this previous tutorial, we're simply gonna load it directly into R. So load it as it is. So the first thing we need to do is we need to create a path to this Nightlight object. And the way to do that is to list the files that currently exist in our main working directory. So that's why here I'm gonna put the main working directory for a path, because this is where I also downloaded. And then for the pattern, I want the pattern that exists in the file name. So this is the one that is gonna capture it. And then finally, I definitely want also the full names to be included in this list. So not just the file name, but also the pathway to this file name. And then finally, we can load this into R. I'm just going to call this Nightlight, and then I'm going to use Terra Rust. Of course, because here we are working with a gunzip file, we cannot simply load it directly using Terra. What we need to do is we need to add one small extension here that will help us do that. So this one is, and we used it also before, this one which handles these gunzip files. And after we added this to our pathway, what we simply need to do next is just add here path to Nightlight. So very importantly, this one here, so this one here comes before your path. Okay, the Nightlight file is also quite big, but thanks to Terra, I loaded this in a matter of a few seconds. You can see though that this is of course the global version, which we're gonna also crop. And you can also notice that the resolution is high, data scope is global, and then also that the coordinates reference system used is WGS84, so it is compatible with the coordinates reference system used for the ship traffic density data. Okay, and we also don't need the global Nightlight pollution dataset, so we can actually crop it to the extent of that bounding box using again Terra crop option. So over here, we're gonna be cropping this Nightlight object. Second, we're gonna be using the bounding box once more. And then finally, we're gonna be keeping only the content that is inside of the bounding box boundaries. Now over here, we don't need to declare zeros as NA values because we want zeros to be dark and we want to paint zeros in that darkest navy blue color. So we're just gonna keep that. But one thing we need to do is make sure that this Nightlight region and that shipping traffic density raster that we also crop have the same dimensions. So for that purpose, we'll be resampling them as we did in one of the previous tutorials. So we're going to be resampling actually the Nightlight region. You can also do it the other way around, but I decided to do this one. So I'm going to create a resample one, and then from Terra, I will be using the option resample. So for resample, you have again three arguments. The first one is what you would like to resample. So we would like to do this Nightlight region. The second one is what is the raster that you will be using for that purpose. So we'll be using this shipping traffic clean. And then the final one is the method argument, and that one depends on whether you have categorical or continuous values. We have continuous values. So we can use one of them, which is called bilinear. And then if you use again TerraPlot for this newly created resampled Nightlight object, you will see actually very pale colors, but you will be able to see at least in gray and some other more warmer colors, the places where you have also night lights, and the white is going to be the one that actually has the missing data. So basically those are going to be that's going to be the C, and this is exactly where the shipping traffic lines are going to fit in as we go to the next stage, which is about mapping. Before we jump straight into writing the ggplot2 code that is going to create our awesome map, we need to define actually our palette first. So I'm going to start off with the nightlight colors here. And what I'm going to do is I'm going to transition from navy blue and blue into yellow and then white. So yellow and white are going to represent those areas with a very high levels of nightlight pollution. And of course, navy blue and this light blue are going to show areas with less nightlight pollution or even darkness. So that's the first thing, and this is going to be manual. Now, for this one, what I would like to do is I would like actually to give a bit more space to these lighter colors so that actually this darkness does not dominate the landscape as we saw actually in the previous map, just created simply with Terra. Now, there is a way to do that. Let me show it to you. So first of all, I'm going to create object nightlight palette. So this is going to be the palette. And then I'm going to use here color ramp palette to increase the number of the values here. So I can, for example, do something like this. I can pass first of all these colors, and then here I can create a bunch of colors. I can, for example, do 256 or whatever you want. Now, how do I make sure that in this sample of 256 colors, there is more precedence given to these lighter colors? So this is where bias kicks in. Bias as actually an option here. So bias, the higher the bias value here, the more space will be given to the distribution of colors to these lower ends. So these lighter ones here. Now bias, I can choose here, for example, 12. But you can see here and play a bit with this one and go ahead and maybe increase or decrease this value and see what fits for you. Maybe you don't want to emphasize that much these nightlight pollution colors, so you might actually opt for a lower bias, or maybe you do want to exaggerate them and then you can increase more. So I found that this one in this specific context works for me, but it's definitely worth exploring it. Okay, so this is for the nightlight palette. Now we're going to go ahead and create some shipping traffic colors. Now for this one, since we're using here navy blue and blue, I didn't want to introduce a third color since we also have yellow. So what I went for, I decided to go just for a blue palettes or color, different blue colors in this case. And here we can just use HCl colors from Bazaar, and this one has a palette which is called simply blues. So here we can define also the number of colors that we want. So for example, 5. You can actually inspect what are the colors that this palette has. And for that purpose, you can use scales package. If you don't have it, you should definitely install it. So scales. And then from scales, you can use show underscore call. So over here, we're going to be passing this object. Then the second thing, we're going to be defining what is the number of colors that we want. So we want 5 because this one has. And then optionally, we can also add labels here. So what this is going to do is once you run this, this is actually going to create a plot, and then you can gauge all the colors visualized that we have. All right, so this is exactly what I was talking about. We do have white in this blue palette. And actually what I'm going to do next is before I enlarge this palette with even more color values, I'm first going to get rid of this white. So I will be getting rid of that one, and I will be creating this shipping traffic palette. So again, we'll be using color ramp palette, but now we will be using only colors from 1 to 4. And to select them, we need to use these brackets and select only 1, 2, 4 again. Okay, and once we have this, what we can do next is exactly what we did above. And that is, well, we don't need to create a bias, by the way, for this one. unless you really want to accentuate the colors. What we can do is also create here some additional color values. All right, and the very last phase of this step is to convert our raster files into data frames so that they can be used in ggplot2. We will start off with the Nightlight data. I will be creating this object, and I will be using for that purpose as data frame function from base R. Over here, I will be passing this Nightlight resampled. And then over here, I want this to be turned into coordinates reference or coordinates, so X, Y, and then to have the third one, which is going to be the value. And then finally, if there are any remaining missing values, you can simply remove them here using this na.rm, which is basically na remove. Okay, and once this is ready, I'm actually going to get here a data frame with 3 columns, so X, Y, and the value column. And the value column here is, of course, the value for the nighttime pollution. So what I'm going to do is change the name of this third column, which is going to be the value, and I'm simply going to change this one to nightlight underscore value. What we did here for the Nightlight data, we should do the same for the shipping traffic data. So I'm just gonna go ahead and rename these. So this one is gonna be called shipping traffic and then DF. And then over here, we need to put that last file that we had for the shipping traffic data, which is shipping traffic clean. And then we basically apply the same thing. All right. And once this is done, we can go ahead and inspect both of these data frames and see how this looks like. All right, so let's go ahead and inspect them. Let's first of all do the Nightlight DF. You remember for this one, we changed the third column. So once you inspect, you will see that it has 3 columns, as I mentioned. So X column for longitude, Y column for latitude, because we essentially turned the raster file into coordinates where every coordinate is the average value, so the central value for each of that raster cells. And then the final one is the Nightlight value, which is that average value for the raster cell. The same things goes for the other data sets, the raster file. So this is the shipping traffic underscore DF. And then once we also run this, you will see a bit different thing. So you will see X and Y, of course, and then ship density global. This is inherited from the main raster file. So I kept it like this, but it's important that you actually then copy this column name, because we will use it in ggplot2 to create our map. All right, and we can finally now write the code that is going to create our map. Let's call ggplot2 and start adding the layers. Now, because we are working here with raster files turned into a data frame, we can either use geomraster or geomtile function in ggplot2. I tried both, but I found that with geomtile, for some reason, the final map has really pale colors. So I decided to go ahead with geomraster, and we will be using here geomraster. We're gonna go ahead and start off with Nightlight data first. So I'm gonna here pass the data frame, and then for the main statics, we're gonna have 3 of them. We're gonna have X and Y coordinates, and finally the fill static, which in this case is Nightlight value. So that's that third column. Once we have this, we can go ahead and also define the fill palettes that will be used to represent the Nightlight values. And this one we also previously defined, and it's called Nightlight underscore palette. Now, normally you cannot add again this scale fill gradient for another aesthetic within ggplot2, but thanks to the package that we installed and loaded at the very beginning, which is called GG new scale, we're actually able to do that. And there is a function here which is called new scale fill, which we will be using. You don't need to add anything there. What you need to do now is add other layers that are using the same fill aesthetic, and then also then define this scale fill palette for it. All right, so in our case, what we want to do is again add this geom raster. What I can actually do here is simply I can copy this and paste here, and then simply change here the data name. So instead of this one, we will be having, of course, shipping traffic DF. For the main aesthetics, we're still using, of course, the X and Y, but instead of this name, we'll be using instead of Nightlight value, we'll be using this ship density global. So then again, thanks to, of course, to this GG new scale, we can also add here scale field gradient for the shipping traffic values. So here we just need to change, instead of Nightlight Palet, we can use this shipping traffic value. Okay, so we added now the main layers. We also defined what is going to be the color palette used, and then finally we can wrap this up with simply themes. So for the base theme, I'm going to be using here theme void, which gets rid of most of the things around it. If you don't find this very inspiring, you can opt for some other theme, and you can also do what I also like to do here, define some additional things within your theme. And one thing I want to do here is I want to get rid of the legend. So I'm going to be defining here that the legend position is none. And then the second thing I want to do here is define the plot margins. Now that means that I want to get rid of any excess white color or black color around this. So I just want to have the image itself. So I'm going to be using plot margin. And then within plot margin, you want to define here units. And then within units, you want to define the list of 4 elements. So you want to define the top one. And I want to decrease them in the same way. So -1 centimeters. I want to decrease the top one. I want to decrease the right hand one. I want to decrease the bottom one. And finally, I want to decrease the left hand one. So -1. And very importantly here, at the end of this one, you need to define what are the units. So I'm going to be using here centimeters. Okay, so once this is done, this is the code. You can actually run this. You can either run as the whole object or just the ggplot2 code. But the next thing is we're going to be saving this object. So once you run this, we can save this object using ggsave. So we need to first of all define here the file name. And of course, you need to use double quotation marks. So we can simply use here traffic, or actually what we can do here, we can call it shipping traffic. And then of course, this needs to have an extension, image extension, PNG in this case, then the plot that you want to save. So this is the map. And then you can also define here width and height. Just be careful because this is going to be in inches. And I'm going to be using here, let's say 7 by 7 inches. So a bit smaller than the default one, which is going to be 10 by 10. All right, guys, and here you can see our final map of ship traffic density with nightlight pollution for these interior areas. And you can clearly see that the higher traffic density is in those areas where there is this white color. So basically not really white color, but it transitions from dark blue to light blue. You can also see, if you actually zoom in into some parts here, for example, that there is also a very vivid river traffic density. So that's also something that is taken into account, which is pretty awesome. Of course, here there are plenty of things that you can change. One of them is, for example, this nightlight pollution. You can make it maybe less accentuated. So you can actually play with that bias option with a color ramp palette and maybe decrease it, see how that works for you. Of course, you can also play with other color palettes. It's all up to you. The whole playing field is out there. I just gave you the tools to create this map. And that's all for today, folks. If you would like to replicate today's analysis, I prepared the link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. I'm also looking very much forward to your own use cases and how you can take this tutorial on a journey across the world. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge with R, I prepared a few cool tutorials for you, so do check them out. See you next time.